Hello and welcome back to this second part of chapter 5 where we're talking about databases. And so here we're looking at question number 4, how do database applications make databases more useful? So to me this is more of the database management system, and so one thing that a database management system will do is you can click on a wizard and it'll automatically build you some forms, and those forms can be used to do all of the different activities that SQL can do. And so that might be to look at your data, insert new or update and delete existing data. They can also generate queries for you, and in Access there's something called Query by Example, or QBE, where it just displays a form and you type in what you're looking for and it tries to build that. The database management system can also generate reports for you, so you can build those reports based on queries or based on tables, if you would. Typically they're going to be based on a query though. And then you can also do some application programs where you're looking at making sure that everything is secure, and then you've got certain restrictions on access to certain people that are using the database, and then you can write code to handle certain situations. So here you can see an example of what do you do if your database is handling stock. That is, when you receive an order that you've purchased something, then the stock is put in, but what happens then if somebody else is trying to purchase something that you have and you're out of stock? Then the database has to be alerted, or a manager has to be alerted saying you're out of stock, and should this automatically do a reorder. And typically that's what's done with, say, manufacturing type of databases. So graphically you might have something like this. You have users that are working on a database, and they're working on these different types of things on their screen. So forms, reports, queries, so on. And that's actually hooked up to a database management system, which I was talking about earlier. And the database management system actually goes and pulls the data out of your database. So when it's doing that kind of this retrieval, you're actually running this database as a database server. So that's another special software in order to meet the demands of what these people, the users here, and sometimes they're referred to as clients, they're making a request, and that gets pulled, and then they see that on their screen. So here we have an example of a report, and so that report was laid out by somebody using a form, and they put in there the field names that they wanted, and then it generates the report for them based on probably a date that they're looking at. So that database management system then could do queries for somebody. They wouldn't have to know SQL or SQL. And they would just type in what they're looking for, press OK, and then behind the scenes it would be writing out the SQL, and then it would retrieve the data that match whatever they were looking for. So in this case, part of the notes was in that barriers to entry. So if we take this exploded view of how it might be used when we're doing any kind of online commerce, you have people that are coming in to your business using their browsers over the internet. Once they see what they want, a web server is going to give them access to the different programs. They're going to make a request to the database management system. It's going to then retrieve from the database. Then notice that depending on the type of software we're using and where in this entire process the entities are, you might have different types of code. So out here under browsers and the internet, you have the use of HTML5, CSS3, which is cascading style sheets, and JavaScript. So someone who wants to work on this side of an application would need to know these applications. Now, on this side, if you want to code directly to the database management system or the database, you might need to know C# or Java or some kind of JavaScript that's a subset, and you would be able to use that in these applications. Here's an example of a form that might be created for the front end of the database. So someone lays all this out, they give the user a list of items they can select from. So in this case, the user collected detail or clicked on details, then it opens up an input form or a retrieval form, and they can then look at additional details if they were to click here, and so on. So that's the front end of a database management system. So here's an example of SharePoint, and SharePoint is a system in Microsoft that allows users to collaborate on various things, and it's hooked up to a database that captures just about everything that goes on to an organization. So in this case, then it's generating a front end where there's different icons where the user can then click on these and get to these items. So it would generate other reports or take other actions for the user. So here we have a graphical representation of what the user might be able to do if we were running a video database. So we might present a front end form that says, okay, what do you want to look at? And they can just click here, and then that would cause an action of going to retrieve all the videos for this particular building. It would probably be also limited by the date in which you wanted to look at those videos. So there might be a range of dates that you could select from. Now, to give you some understanding of what kind of problems a database can give you, your book mentions something called the lost update problem. So here we have two people that are looking for the last two tickets at an event. Right? So they're Jeffrey and Andrea. And so what happens in a database to prevent this is there needs to be some kind of locking mechanism. And so the database administrator may lock out a record or lock out a table until the transaction is complete. And what's showing here is what could happen if you're not locking out your tables. So the process flows like this. Andrea logs into a site and it shows that there's two items left, two petals if you will. Jeffrey also logs into the site after her and it shows that there's two petals. Andrea puts the petals in her shopping basket but doesn't check out right away, so she may continue shopping. But Jeffrey goes ahead and checks out before Andrea. So now she's still got these two items there, and there's no items left. So now she proceeds to check out, and there causes an error because the inventory is down to 0. So again, you got to have some kind of lockout mechanism. And this will typically occur when you're going from a single user database to a multi-user database. So again, that causes more work for the database administrator, but they've got to run things so that people will get what they've ordered and not have, this kind of activity happen to them when they get to checkout and then all of a sudden they realize, hey, those items are no longer in inventory and you can't really buy them. So that just causes frustration on the end user's part. So if we go back to our opening vignette, so how can Falcon Security benefit from a database system? One thing that would be beneficial is they'd be able to query for videos in a certain time frame. They could also query about videos that were shot at different heights. And so in this case, they want something in October 2014 and shot from 3,000 feet or less. So they ought to be able to query for that. Now, they won't be able to find that data unless the data is somehow put into a database and categorized that way. So it's going to have a lot of effort on getting that data in to find out how people want to get it out. So my point here would be is that as managers, if you're designing a database, you got to think about how are people going to use this database. And then that's how you got to capture the data and then organize the data so that people can query it and get that information out that they need in their reports. Now, the solutions presented here are that they could store their videos on a server and then keep information or metadata about each video in a relational database. So, and that's typically what was done in the past in terms of that information's in there, and then there's just a field that's a link to the actual video. So you're not actually storing that video content in the database. It's just a link to it, so you know what the name of the file is that contains that information. And they can also use another database that's used with a lot of web queries and stuff, and it's MongoDB, which we mentioned earlier. It is no SQL type of database. That's not to mean you can't use SQL on it. It's just that the way they collect the data and organize it, you can actually get information out without doing that, without using SQL. Also, the NoSQL means non-relational databases there. And you may, because of the way data is collected today, as managers, you may be exposed to more non-SQL databases like MongoDB. So continuing on to answer these questions, one question might be, what are non-traditional database management system products? And those are the ones that where a relational model is not needed today. So if you're doing a query, say from Google, do they really need a relational database to store all of the queries that somebody might retrieve? The problem with a relational database is that if your querying requires multiple tables, then you got to load those tables into memory, and then they have to be associated or linked in memory, and that takes forever. And you can only imagine how many records a Google database it contains, or a Google table, and so that would just be too slow. And so they use these non-relational databases in order to store that information for a Google search. You know, some things that you need to understand though is that there's this concept of called ACID, and that means that new types of data typically have to be atomic, consistent, isolated, and durable, and then we're looking for those type of transactions. The idea of atomic means that if I have a transaction, that means one table is updated based on something else being updated somewhere else. So a transaction might be you registered for a class. Well, when you register for a class, you're taking up a seat. So when you take up a seat, the number of seats available should be reduced by 1. Until both of those items are updated, then that's not considered a complete transaction. So atomic means either the entire transaction is completed or it's not. Consistent then means that it has to be processed the same way every time. And then isolated refers to whether it's processed either by itself or with other types of transactions. And then the last part, being durable, means that once the transaction is stored, it never goes away, even if there's a failure of the database. So it needs to be saved, needs to be a way to recover that. And so as managers, you need to understand that this is, really critical to a transaction over the web or any kind of transaction. If any of these are not true and they fail, then your database isn't going to be reliable, which means that your reports aren't reliable and you're making decisions with bad data. Now, along those same lines, you have applications like Twitter, Facebook that may not require those type of requirements for a database. So you don't see the ACID requirement. And so some specific names that you may be seeing when you get out there. is databases like Dynamo, Bigtable, Cassandra, TLP, and these were all developed because we need faster performance from these databases and database servers. Like I mentioned earlier, a relational database is going to be very slow, and so when we're wanting to do fast queries and things, it's going to have to be something that's much faster. So you may be on a project where you're evaluating these servers, and you'll need to have a little better understanding of those. But here's just some idea of some names and things that are out there. So some non-traditional relational databases. We've talked about what NoSQL means, non-relational. So it's high transaction rates, and very simple data structure. So you might have just one table. You're not going to have to link up a bunch of different tables. They can be replicated. That means copied and backed up and used over again on different servers. So if you're somebody like Google, you're going to have that information on different servers in different parts of the world. So your people that are querying that information, it's going to work faster. Right? Some examples then are what we just talked about. Now you may still need to have some database management systems that process very quickly. They're similar to NoSQL, but they provide some ACID support. Right? They may or may not be a relational model. That is, they can't link tables. Right? So there's a lot of development going on in this area right now. Some examples that you might see of some in-memory database management systems: SAP, HANA, or Tableau. I know we use Tableau in our program here to grab data and present it in a graphical form so people can make decisions with that. And so you might categorize these type of databases as high volume ACID transaction support with complex relational query. So you may be asking yourself, will these products replace the relational model and the relational databases? There's probably always going to be a demand for a relational database within an organization, so they probably will not replace those. But they may be used side by side, and you'll need to have some understanding of both of those. And so as you see more and more people develop products for this area, maybe you won't have just Microsoft and IBM and Oracle as the three big database providers in the business world. So a little competition might drive the price down and drive the support for different databases down. So hopefully then, this chapter gives you an understanding and the purpose of a database and the different categories of relational databases and non-traditional databases. And that if the need comes about, that you need to know the impact of choosing the correct database management system for your organization, you now have some exposure to that. And so that ends this chapter.